This is the demonstration video for your tool which is named as Proteas 8 Professional. It is present on your desktops. You will double click on this and this window will pop up straight away. You have to click on New Project. It is detecting compilers and you have a new project like this created. You can name it as you like and then click on Next. Here everything is to be kept as default, that is create a schematic for the selected template, default, and click next. Now here do not create a PCB layout. We are not going for PCB layout as of now because that will be beyond our levels as of now. So let's keep the settings as it is again and click on next. Here we have to go for create a firmware project, okay? Because we have to select a firmware and here our firmware is 8051 family. And in that 8051 family, we are specifically talking about 80C31. It is the default version, so let's keep it as it is. Although we have all other options available, 31, 32. Let's not disturb this template and let's click on next. We have schematic and firmware both associated. Click on finish. Now this is our firmware and this is our program. If you just look at this corner, here you have the schematic, so you can see the schematic of your microcontroller. Okay, these are the different ports, you have crystals, all things are attached by default with this. You need not to do anything with the schematic because we are dealing with the code. So you click on the source code. Now you have this file over here where there are certain number of things written by default. You can either keep it as it is or erase all. Now let's write the program. Now this is the piece of code which I have added as of now. I have just added 2 lines over here. This 00 is the origin and we can either erase all of this and write these 2 lines directly, but this will help us to jump to start, and we have where we keep the start we have to use org, that is origin for the start is 100H hexadecimal again. Now let's look at this schematic capture. As you can see, the port P1 as of now displays nothing. There is no LED over here. You will see red or blue scare dots appearing at this port P1 as we execute the program. So because I am sending a data 1 FF on port P1, first I am taking that to accumulator A, then I am sending that accumulator to port P1. So that means all the LEDs on P1 should glow. Let's see what will happen. So you might also see an error over here, firmware error, but you have to ignore this for now. And let's compile this straight away. Once you compile this, it will take you to the schematic, and as you can see, all the LEDs on port 1 have become red because of data 11. Now let me go to the source code again and I will stop this by this button. So this has stopped. Now let me send data F and 0, okay, to the port P1. I will simulate it again using this button. So it has been simulated, and as I can see that some 4 bits are 000 and another 4 are 111. You can see rest all LEDs are also glowing, that they are red, or some do not glow, but we should not be worried about them because that is the default state of all these pins. We should be worrying about only that port where we have sent some data. So you can see these blue LEDs. Blue LEDs means 0 and red means 1, or it can be vice versa, which will depend upon how we move ahead with the program. We can come to know that. Now suppose we will stop this again and we send some data. Yeah, red means, by the way, 1. Now let's say and I send some data A. AA means 10101010. So there will be alternate glowing of LEDs. So let me compile it over here and it will take me to the schematic, and in the schematic I can see a Pin 1 is 0, pin 2 is 1. 0, 1, 0, 1. So this is how it works, and this is how you will execute your program. Whichever program you write, you have to send the data to any of the ports to visualize it better. Thank you.